Welcome. Today we're going to talk about and introduce three-dimensional figures. Let's start from the very beginning. 0 dimensions. The only geometric object with 0 dimensions is a point. In 1 dimension, there are several. There's lines and any segment or ray or part of a line. And the 1 dimension that we can measure is called the length. So a 2-dimensional object includes many of the objects we've already studied. They have 2 dimensions, length and width, and that would include all the polygons and circles, anything flat. And now we're going to introduce 3 dimensions. The 3 dimensions are length and width and height. And when you hear that something is 3D, that's what they're talking about. It looks as if it has 3 dimensions, and that it's not just flat on a 2-dimensional screen. So 3-dimensional figures have 3 dimensions, length, width, and height. A flat surface of a 3-dimensional figure is a face. So that would be a side, such as the top or the bottom. An edge is where 2 faces meet. So these are important vocabulary words, that's why they are in red. Please highlight them for yourself, and in the Cornell style, come up with a question like, what is a face or an edge? And so we go on. A polyhedron is a 3-dimensional figure whose faces are all polygons. So that when you had a basic 2-dimensional figure, we called it a polygon, and now a basic 3-dimensional figure is a polyhedron. And the vertex of a polyhedron is the point where 3 or more edges meet. So now we have 3 important parts of the polyhedron. We have the face and the edge and the vertex. And that's a 2-dimensional and a 1-dimensional and a 0-dimensional aspect of the polyhedron. Finally, the face that is used to name a polyhedron is called the base. So in a polygon, we called the base was the edge that it sat on. Now in a polyhedron, the base is a whole face. It will be a polygon, and we'll use that to name the polyhedron. The first 3D object we're going to talk about is a prism. A prism has 2 parallel bases that are congruent polygons. So that means the top and the bottom are identical. And lateral faces, those are the sides, that are parallelograms. Okay? Now remember, rectangles are parallelograms. So when you have a regular prism, then those lateral faces become rectangles. But if it's a little bit wonky, they turn into parallelograms, and it's still considered a prism. So you're going to try to draw a prism. That's a 3D box. And label a base and a lateral face and the other base. And the bases are identical. This is also a prism. What shape is its base? That's right, it's a triangle. So that's what we name it by. It's called a triangular prism. This is what the net of a triangular prism looks like. So if you wanted to make a triangular prism out of cardboard, you could cut out this shape, and when you fold it up, it would create a triangular prism, because that's its net. What shape is the base of this prism? Yeah, I would say rectangular, and so this would be a rectangular prism. It's the name of this shape. And let's draw the net of a rectangular prism. It's going to be 8 rectangles. And when you fold that up, it would create a 3D rectangle. Okay, so today's a lot of vocabulary and drawing, and not much math actually. So let's see. What shape is the base of this one? So how many sides does it have? It has 5 sides. Therefore, I would call that a pentagon. And we would call this a pentagonal prism. That comes from the word pentagon. We change it to an adjective because it's describing the prism, so it's pentagonal. So 5 sides, and then made into 3D. So the base is a pentagon. Here's what a pentagonal prism would look like: 2 pentagons and 5 rectangles. I know they look like squares, but it could be taller. They don't have to be squares. Here's yet another prism. Count the sides. I see 6. What do we call a 6-sided polygon? That's right, we call it a hexagon. So this will be hexagonal. Change the word hexagon by putting AL on the end to an adjective. It describes the prism. It's hexagonal. Here's a net, 2 hexagons, and this time, because it has 6 sides, it's going to have 6 rectangles connecting those 2 hexagons when you fold it up. Okay, so drawing the net, not that hard. You need the top, the bottom, and all the sides. Here's a cube. A cube is a special type of prism. It's one in which all the sides are squares of the same size. They're all congruent squares. And you can see that has 6 sides, right? Like a die, it would have a top and a bottom, a left and a right, a front and a back. The next main shape we're going to talk about is called a pyramid. A pyramid has a base that is a polygon, and then lateral faces that are triangles. And it only has one base. And on the other side, instead of another base, it has a vertex, a point at the top. So the lateral faces are the sides, and those are always going to be triangular, no matter what shape the base is. In this case, it looks like the base is a square, but other ones can have different shaped bases. So, what shape is the base of this pyramid? It's square, so that would make this a square pyramid. Let's take a look at its net. It's going to be 1 square and 4 triangles, which would meet at the top. A cylinder has 2 parallel bases that are congruent circles. And, well, that's pretty much your definition of a cylinder. And please draw one. Take a look at the bases. So the net of a cylinder could look like this. Try to make the circles identical to one another. And when you unroll it, it's like taking the label off a soup can. You'll get a rectangle. A cone has 1 circular base and 1 vertex. I like to think of this as a circular pyramid. The base would have a radius, and you can see there's a height involved for the vertex. Here is the net of a cone. You can see the circular base, and if you unwrap the ice cream cone part, it's going to look like a section of a circle. Finally, a sphere is the set of all points in space that are a given distance from a given point, called the center. It's very similar to our definition of a circle. We just replaced on a plane with in space. So we have a 3D circle, or a ball. And it has a radius which we can measure. A famous drawing of a sphere by an artist you may recognize. That's right, it's M.C. Escher.